Hello everyone. Today we are going to study class 8 science chapter 4, that is metals and non-metals. So in this chapter we are going to discuss the properties of metals, non-metals and their uses. So let's start with matter. What is matter? As already we know that anything which occupies space and has mass is called matter. For example, chair, table, bucket, shirt, spoon, everything is matter. Matter is divided into elements and compounds. So what is element? Element is a substance which cannot be split up into two or more simpler substances by usual chemical method. That means a substance which cannot be broken into smaller pieces is known as element. For example, iron, oxygen, magnesium, etc. So now elements can be classified into metals, non-metals and metalloids depending upon their physical and chemical properties. So what are metal, non-metals and metalloids? So metals are hard and shiny in appearance. Example, iron, copper, tin, gold, etc. Non-metals, they are not so hard. Most of them have dull appearance. For example, sulfur, phosphorus, hydrogen, oxygen, etc. And what about metalloids? Some elements have certain properties of metals and some properties of non-metals. These are known as metalloids. So elements can be classified into metals, non-metals and metalloids. So occurrence of metal. The earth crust is the main source of metals and some non-metals. Almost all the rocks contain some metallic minerals. Those minerals from which the metals can be extracted profitably are called ores. In ores, certain impurities are present along with the metallic minerals and these impurities are known as gangue. In the earth crust, metals are found in their combined state or in free state. So how extraction of metal is done? So the process of obtaining metal from ore is called extraction of metal. The various processes involved in the extraction of metal is called metallurgy. So let's start with the physical properties of metal. So first is physical state, solid. Most of the metals are solid at room temperature. Mercury is the only metal known to occur in liquid state in nature at room temperature. No metal exists in gaseous state. Second is strong and hard. So most metals are generally strong and hard. They are difficult to break down and smaller pieces and changing their shape usually involves a lot of efforts. Ductile. So most of the metal can be drawn into thin wires. So the property which allows the metal to be drawn into thin wires is called ductility. Gold and silver are among the best ductile metals. Copper, aluminum, iron and magnesium metals can be easily drawn into thin wires. Next is malleable. The property which allows the metals to be hammered into thin sheets or foil is called malleability. Most of the metals are malleable. Gold, silver, aluminum, copper are highly malleable metals. Because of this property of metals, they are very useful to us. For example, aluminum foil are used for safe packaging of foodstuffs, medicine, etc. Next is high melting and boiling point. Most metals have high melting and boiling points. They need to be heated to very high temperature before they melt to become liquids. Sonorous. Metals are sonorous. That means this property refers to the sound that metals make when they are hit. Metals make a ringing sound when they are struck. Conductors. Metals are good conductor of heat and electricity. So metals are good conductor of heat. For example, silver is the best conductor of heat, followed by copper. Aluminum and iron are also good conductors of heat. For this reason, metals like aluminum, iron and copper are used for making utensils and water boilers. Metals are good conductor of electricity. All metals are good conductor of electricity. Silver metal is the best conductor of electricity. Copper wires are used in electric wiring and aluminum wires are used in electric cables because copper and aluminum are good conductors of electricity. Shiny and silvery. That means metallic luster. How they show metallic luster? Most of the metals are lustrous, that is they have a shiny surface. This property is called metallic luster. The shiny surface of metals makes them good reflectors of light. Because of their metallic luster, gold, silver, platinum metals are used for making jewelry and decorative articles. Dense. Most metals have high density. This is the reason why they feel heavy and sink when placed in water. That means they have high density, but sodium and potassium have low density. Now, physical properties of non-metal. What are the physical properties of non-metal? So, non-metals are generally solid or gases. Non-metals like sulfur, phosphorus and carbon are solids. Non-metals like hydrogen, oxygen and nitrogen are gases. Bromine is the only non-metal which exists as liquid at room temperature. Malleability. Non-metals are not malleable, but they are brittle. So what is brittle? The property due to which non-metals breaks up into pieces on hammering is called brittleness. Non-metals are generally brittle. For example, sulfur and coal breaks up into small pieces on hammering. Ductility. Non-metals are non-ductile. When stretched, non-metals like sulfur and phosphorus breaks into pieces and do not form wires. Sonorous. Non-metals are non-sonorous. That means it cannot produce when hit with a hammer. So non-metal do not make a ringing sound when we strike. Density. Non-metals have low densities and they are very soft, but diamond has high density. Melting and boiling point. Non-metals have low melting and boiling points. For example, the melting point of sulfur is 115 degrees Celsius. However, diamond has a very high melting point. Conductor of heat and electricity. Non-metals are poor conductor of electricity. For example, sulfur and phosphorus are non-metals and they do not conduct electricity. However, graphite is a non-metal which is very good conductor of electricity. Non-metals are poor conductor of heat. Diamond is the only non-metal which is good conductor of heat. So, difference between physical properties of metals and non-metals. So, metals are solid except mercury. Non-metals may be solid, liquid or gases. Metals are hard except sodium, potassium, etc. Non-metals which are solids are brittle. Metals have metallic luster. Non-metals do not have luster. Some metals have a dull luster. Metals have high melting points and boiling points. Non-metals have low melting boiling point. Metals are malleable. Non-metals are non-malleable. Metals are ductile. Non-metals are non-ductile. Metals are good conductor of heat and electricity. Non-metals are bad conductor of heat and electricity. Except graphite, metals are sonorous and non-metals are non-sonorous. So, chemical properties of metal. Generally, all the metals show similar chemical properties, but their reactivities depend upon their nature and reaction conditions. So, first we are going to discuss reaction with oxygen. Metal react with oxygen to form metal oxide, which are basic in nature. Most of the metal form basic oxides. So, when magnesium metal burns in air, it combines with oxygen of air to form magnesium oxide, that is white powdery substance. So, magnesium when burnt in oxygen, it will form magnesium oxide, that is basic in nature. Next, what happens when sodium is left in open air? So, when sodium metal react with oxygen at room temperature to form basic oxide called sodium oxide. Sodium metal is stored in kerosene because it can catch fire on reacting with air. So, it is kept inside the kerosene. So, we have a equation that when metal react with oxygen, it will form metal oxides. So, metal oxides are basic in nature. So, how can we show that metal oxides are basic in nature? When we dissolve metal oxide in water, they partially form metal hydroxide solution. And this metal hydroxide solution, when combines with water, they form metal hydroxide, which turn red litmus blue, showing that it is a base. Thus, metal oxide is basic in nature. Reaction with water. How metal reacts with water? Metals react with water and displace hydrogen from water to form metal hydroxide or metal oxide and hydrogen gas. So, the reactivity of different metals with water is different. Sodium and potassium react violently with cold water to form sodium hydroxide and hydrogen and catches fire. Calcium reacts less violently with water to form calcium hydroxide and water and does not catch fire. Magnesium reacts only with hot water to form magnesium hydroxide and hydrogen. Metals like aluminum, iron and zinc react only with steam to form the metal oxides and hydrogen. And metals like lead, copper, silver, gold do not react with water. So what is the reactivity series of metal? So metals are arranged in a series according to their chemical reactivity. So the arrangement of metals in a vertical column in the order of decreasing reactivity is called the reactivity series of metals. In the reactivity series, the most reactive metal is placed at the top, whereas the least reactive metal is placed at the bottom. So here we can see potassium, sodium are the most reactive, so they are placed at the top, and silver, gold are the least reactive, so they are placed at the bottom. So in any reaction, a metal can replace another metal if it is placed above the other metal in a reactivity series, but it cannot replace a metal which is placed above in the series. So reaction with acid. Metals react with acid to form respective salts and hydrogen gas. See the reaction. When zinc reacts with hydrochloric acid, it forms zinc chloride and hydrogen gas. Magnesium reacts with hydrochloric acid, it forms magnesium chloride and hydrogen gas is released. Aluminium reacts with hydrochloric acid, it forms aluminum chloride and hydrogen gas is released. The reactivity varies from metals to metals. For the above metals, the decreasing order of reactivity is magnesium is more reactive than aluminum, aluminum is more reactive than zinc, and zinc is more reactive than iron. Copper, silver and gold do not react with dilute hydrochloric acid. Hydrogen gas is not evolved when metal reacts with nitric acid because it is a strong oxidizing agent. It oxidizes the hydrogen produced to water and itself reduced to oxides of nitrogen. Reaction of metal with metal salt solution. So what happens when metals react with, and this is known as displacement reaction. So from the metal reactivity series, we know that when the more reactive metal is added to the salt solution of less reactive metal, the more reactive metal displaces the less reactive metal from its salt solution. Such a chemical reaction is called displacement reaction. So how can we define displacement reaction? The displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its salt solution. So for this we are going to explain a simple activity. So we have taken test tube, then iron nail, piece of copper sulfate solution, iron sulfate solution. So what we have done, we have taken copper sulfate solution and we have added copper sulfate solution and we have added iron nail. After some time, the color of the blue copper sulfate changes to green due to displacement reaction. So what is that reaction? When iron reacts with copper sulfate, it forms iron sulfate and copper is released. Why this happens? Because iron is more reactive than copper, so it displaces copper from the solution of copper sulfate, and the color of the solution slowly changes from blue to green due to formation of iron sulfate. Now chemical properties of nonmetals. How the reaction of nonmetals occur? Reaction with oxygen. Nonmetals react with oxygen to form non-metallic oxides. When sulfur is heated, it combines with oxygen to form sulfur dioxide. And when carbon is heated, it combines with oxygen to form carbon dioxide. Reaction with water. Generally, nonmetals do not react with water though they may be very reactive in air. Such nonmetals are stored in water. For example, phosphorus is a very reactive nonmetal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Reaction with acid. How nonmetal react with acid? So nonmetals generally do not react with acids. So what are the uses of iron? What are the uses of different metals? How they are used? So iron is used in making pins, nails, nuts, bolts, tool, machine, construction of building, bridges. Wrought iron is tough and malleable with very little carbon content, so it is used for making bolts, chains, wire nets, nails and agriculture tool. Stainless steel, it is an alloy of iron and it is used for making utensils, knives, etc. Aluminium, it is used for making utensils and electrical cables due to its high conductivity of heat and electricity. It is used for making paints to prevent rusting of iron, and it is used for making body parts of aircraft because it is very light and strong. How copper is used? Copper is used for making electrical wires, cables, coils of various electrical appliances because it is a good conductor of electricity. It is used for making utensils, car radiators, calorimeters because it is a good conductor of heat. It is also used for making alloys which are used in making coins, pipes, etc. How gold and silver are used? They are used for making jewelries and decorative items because they are lustrous, highly malleable and ductile. What about platinum? It is used for making jewelries and electrodes for electrolytic cells. Another is sodium. Compounds are used as common salts, chemicals, etc. Calcium. Compounds are used for making cement, glass, etc. Chromium. It is used for electroplating an iron object. It is used in car bumpers and handles of bicycle because of its corrosion resistance nature. Zinc. It is used in dry cells, galvanization, alloys such as brass and German silver. What are the uses of non-metals? How they are used? So sulfur, it is used for making sulfuric acid, salts of metals and etc. It is used in skin ointments, spray for fruit trees against pest and disease because of its fungicidal and insecticidal nature. Next is oxygen. How oxygen? It is used in respiration and supporter of combustion. Nitrogen, it is used for manufacturing fertilizers, ammonia and nitric acid. And liquid nitrogen is used to preserve blood, cornea and body organs. Hydrogen, how hydrogen is used? It is used in extraction of metals such as copper, lead and tin. It is used for manufacturing ammonia. How chlorine is used? It is used for disinfecting water and manufacturing bleaching powder, PVC pipes and plastics. Iodine, it is used for preparing iodized common salt. It is used to prepare tincture of iodine which can be used as antiseptic. So what is corrosion? The process. So what is corrosion? The process in which metal is eaten up by action of air, moisture or a chemical on their surface is called corrosion. So what are the day-to-day example of corrosion? So silver article becomes black after some time when exposed to air. This is because it reacts with sulfur in the air to form coating of silver sulfide. Copper reacts with moist carbon dioxide in the air and slowly loses its shiny brown surface and gains a green coat. This green substance is copper carbonate. Iron, when exposed to moist air for a long time, acquires a coating of brown flaky substance called rust. So iron, when combines with oxygen and water, it forms hydrated iron oxide. So what can be done to prevent corrosion? So corrosion of metal can be prevented by preventing their contact with air and water. It can be done by applying oil or grease. Oil, grease or paint is applied on the surface because it keeps the metal away from the air and moisture. Galvanization, a layer of zinc is deposited on the surface of iron object by dipping it in molten zinc. This process is known as galvanization. Electroplating, a layer of another metal is deposited on the surface of metal object by the process of electroplating. And alloy. What is alloying? Some metals or non-metals are mixed with the metal objects by the process of alloying. So let's start what is alloy. So a homogeneous mixture of two or more metals or metals along with some non-metals is known as alloy. So what are the characteristics and uses of alloys? Alloys are generally hard. For example, carbon is added to iron to increase its hardness. It forms an alloy called steel which is used for construction of ships, bridges and vehicles. Alloys are generally resistant to corrosion. For example, alloy of iron, chromium and nickel is known as stainless steel. It is resistant to corrosion and it is used for making cutlery, utensils, surgical instrument, etc. Alloys have high tensile strength. For example, chrome steel is an alloy formed by mixing Iron and chromium, it has high tensile strength, so it is used for make XL cutting tools, etc. Some of the alloys have low melting point. For example, solder is an alloy made by mixing tin and lead. It shows it has lower melting point than tin and lead, thus it is used for joining electrical wires.